All right, so we're going to head back here into Chapter 3. In Chapter 3, again, we're going to be covering decision structures and Boolean logic. So this is going to kind of introduce you to this kind of fundamental idea in programming that if this, then this, right? So, if something is true or if something is false or some value is greater than or less than or whatever it might be, then you execute these certain bits of code. Otherwise, do these other sorts of things. So again, the topics that we're going to be covering, the if statement, obviously, which is sort of this single alternative decision structure. We also have the if else, which is sort of a dual alternative. And then we have multiple alternative, which is the if else statement that we have. And again, keep in mind, we're going to be learning Python, right? So we're learning Python as a specific application, but these ideas, the concepts of these decision structures exist in all code bases. So in Java, in C, in Ruby, in PHP, all of these sorts of coding languages are going to have sort of the same idea in terms of decision structures. So again, I'm going to teach you specifically Python, but it's good in your mind to sort of generalize this idea that these also apply to other programming languages. So a few definitions really quick. A control structure is a logical design that controls order in which a set of statements execute. So a control structure is going to be the way a program executes from top to bottom. Okay, so the control is going to be how it moves through execution. It's going to be made up of sequences and decisions and all of these sorts of things. A sequence structure, set of statements that execute in the order they appear, right? Okay, so it's going to go from top to bottom. Decision structure, again, is specific actions performed only if a condition exists. Okay, so again, the sequence structure is something that we're going to see a lot, right? A program is a sequence structure. When you break it down, even with loops, it's going to be one thing after another. A statement that executes, and then another statement, and then another statement, and then another statement. Okay, a decision structure then is going to alter that sequence structure depending on the conditions of the input or of the computing environment, right? So the sequence structure may loop 10 times, it may loop 20 times based on a certain decision structure or user input. Okay, so again, the sequence structure, when you break it down, it's going to be finite. It's going to have a beginning, it's going to have an end, unless you have an infinite loop, and that's definitely a problem. But in general, we can sort of break all programs down to a sequence of instructions. So just breaking it down into this initial idea of an if statement. Okay, so we're going to see a flowchart here, but we don't really cover the flowcharts to define this if statement. But essentially what an if statement is if some condition is true, then do a thing, right? So actions are conditionally executed. If some condition is true, then do these things, right? For instance, if age greater than 18, then do this. Or if income is less than this, then print this. If, name starts with A, then do this, right? So that's just a very simple concept that given a condition is true, some set of statements can be executed. Okay, and this is called, with just the if statement, it's called a single alternative decision structure. It's this right here. It provides only one alternative path of execution. So let's say I have an if statement, and I'm going to go ahead and just push it over here. And again, we're back here in PyCharm. We're going to go ahead and create a new Python file. We're going to call it Chapter 3. Okay, so if I have an if statement, the way that's going to look is if, and then I can have some condition, right? So if 10 is greater than 5. Okay, now that's always going to evaluate to be true, but we can actually run that. So print this is true. Okay, so now if I execute this, obviously it's mad because it's always true, but this demonstrates to you exactly what that means. So 10 is always greater than 5. Okay, now one way we can kind of make this a little bit more complicated is we can say, hey, age equals 10. Okay, so if age is greater than 5, then we can say this is true. Okay, so I'm going to execute that, and now age is 10, 10 is greater than 5. Now we can make that even more generalized, right, where I can say age equals input, and then I can say enter age, right? So that's going to go ahead and give me that chance to enter that age. Now, down here, since we learned from last chapter, the input function always generates a string output. So this age right here is going to be a string. So it's going to have some confusion right here unless I force that to be an integer. Okay, so I'm going to go ahead and force that to be an integer. I'm going to eliminate that. And so now we have the situation where if age is greater than 5, then this is true, right? So I can execute this. I can say 10, and it says this is true. Now if I execute it and I say 21, then it's true. Little fudge there. If I hit 2, now it's not going to print that, okay? So in this situation, we have this single alternative decision structure. Now to show you how this goes from top to bottom, I can then print this program is done, okay? So you'll see if I enter something that proves true, if I say 10, this is true, and then it says this program is done. If I run that again and I enter 2, it's just going to say this program is done, okay? So you could visualize that the program starts here, it works down, and then if age is greater than 5, it goes here, right here, and then it goes down. Otherwise, if age is not greater than 5, it just skips this and executes this. Okay, so that's a single alternative decision structure, provides only one alternate path of execution. In this example, the alternate path is print this is true. Okay, so that's your single alternative decision structure. The way that it works is cold outside, true, wear a coat, false, just skip it. Okay. So in Python, as you've seen, the syntax here is if a given condition, then do statements, right? So the first line here is known as the if clause, okay? So I define the if clause right here. If age is greater than 5. And again, you can define that as hard-coded, which is kind of silly, but it shows you if 10 is greater than 5, then do this thing, right? So that is what we call the if clause. Now, again, it can either be true or false, as we showed. You know, if it's greater than 5, then it goes into it. If it's not greater than 5, then it doesn't. So again, a few more concepts here before we keep moving forward into maybe a dual alternative structure. So we have these things called Boolean expressions. Okay, Boolean expressions. I know Boolean is probably a new word. Maybe you've been exposed to it, maybe you haven't. Basically, it just means true or false. Anytime you see Boolean, it just means true or false. There's nothing confusing about it, nothing complicated, just true or false. That's it. Boolean can be 0 or 1, true or false. Well, actually, false or true. 0 is false, 1 is true. Okay, so a Boolean expression is an expression tested by an if statement to determine if it is true or false. Okay, so right here, where is our Boolean expression? Our Boolean expression is right inside of these parentheses. If age is greater than 5. Okay, so this will either evaluate to true or false. Okay, so when I run it with 10, okay, if 10 is greater than 5, so 10 is greater than 5, so that'll evaluate to be true. This is true. Okay, I could do it again, and I can put in 2. If 2 is greater than 5, is 2 greater than 5? That is not true, so that is false. So since this is false, it will skip that. Okay, this program is done. Okay, so the Boolean expression, again, comes out to be true or false in an if statement or a decision structure. It needs to be true. If true, then do this. Okay. Example, A is greater than B. If A is greater than B, then false otherwise. And we've already seen that. Okay. So this right here obviously introduces a new concept. It's called a relational operator. Okay. You'll need to remember that term. Relational operator, it determines whether a specific relationship exists between two values, right? Is it greater? Is it less? Greater than or equal to? Less than or equal to? Equal? Not equal? So on and so forth. We'll go over those a lot more later. And again, in Python, we actually can expand some of these ideas. Okay, so we have greater than and equal. Okay, so that obviously means greater than, equal. This means less than or equal, right? So we can say if it's greater than or equal to, it's less than or equal to, so on and so forth. Now, keep in mind, and I see a lot of students get confused by this one, this equal determines whether they are equal to one another. This single equal is assignment. Okay, so equal determines if they are equivalent. Equal is an assignment. Please do not confuse those. Okay, I will probably ask you this on a test. Okay, the assignment operator assigns a value to a variable. Okay, so we can see here I use the assignment operator to assign the output value of this input function to the variable called age. So I have assigned a value to age. We can simplify that by saying 10. Okay, so now I have assigned 10 into this variable age. All right, then I can check to see if it's true by doing something like this. If it's equivalent is like this. Okay, so age is 10. It is set to 10, so that means that we can just sort of fill 10 in here. 10 is equal to 10, so it should print true, right? So if I run it now, this is true. If I set it to 11, 11 is not equal to 10, so it will not run. This is true. Okay, so remember, this test if they are equivalent, equals equals, this assigns. Okay, so keep those straight. Now, obviously, sometimes it's necessary for us to just check to see if it's not equal to something. If it's not equal to 10, then print something. Okay, and the not equal operator is exclamation mark equal. Okay, so I could say age is 11. If int age is not equal to 10, then we'll print this as true, right? So 11 is not equal to 10, so we should get into this part of the decision structure. So let's go ahead and run that down. Says this is true, right? If I actually put this as 10, then it's going to do the opposite of that, right? So 10 is equal to 10, so it's not going to actually evaluate to true. So it just says this program is done, okay? So that's sort of how that not equal to operator works. So again, these Boolean expressions, relational operators, kind of break down to this little chart right here, right? So the Boolean expression is x is greater than y. The relational operator is greater than. Okay, this breaks down to is x greater than y. X greater than y. This one is x less than y. This one is x greater than or equal to y. This one is x less than or equal to. This is x is equal to, y, and this is x not equal to y. Okay, and so obviously you have these slides on the actual page, so I would encourage you to pull those down and make sure that you memorize these things. We're going to be using these relational operators a ton throughout this class, so I would encourage you to memorize those. Go into your Python and just test them all out, right? Set an x, say x equals to 10, y equals 20, and then just go ahead and play around with these, right? X greater than y. Okay, so x is not greater than y, so obviously we're going to know how that evaluates, right? X is 10, y is 20. It's just going to say this program is done. Now, if I reverse that and I say less than, x is less than y, we're going to get this is true, right? Because 10 is less than 20. I can do less than or equal to. I can do greater than or equal to. I can do not equal to. Okay, so if they're not equal to, we're going to evaluate to true, right? Because 10 is not equal to 20. Okay, so I encourage you to go down, sort of look at those sorts of things. Okay, so again, this is how these Boolean expressions work with the relational operators. All right, so we're going to jump into another video here. It looks like we're going for about 12 minutes, so we're going to go ahead and take a little break, jump back on the other side with a little bit more on these Boolean expressions and relational operators.